Good morning. The topics that I'm going to discuss today are the binomial probability distribution and related topics. For the introduction to random variables and probability distributions, for the random variables, we have discrete and continuous. When the observations of a quantitative random variable can take only a finite number of values or a countable number of values, we say that the variable is discrete random variable. For continuous random variable, when the observations of a quantitative random variable can take on any of the countless number of values in a line interval, we say that the variable is a continuous random variable. We have here, for discrete, countable. For continuous, this one is measurable. For probability distributions, a random variable has a probability distribution whether it is discrete or continuous. The probability distribution is simply an assignment of probabilities to specific values of the random variable. Okay? Again, how do we assign probabilities? It is by intuition, relative frequency, or equally likely outcome. The probability distribution of a discrete random variable has a probability assigned to each value of the random variable, and the sum of these probabilities must be equal to 1. For our example problem, one of the elementary tools of cryptanalysis, the science of code breaking, is to use the relative frequencies of occurrence of different letters in the alphabet to break the standard English alphabet codes. Large samples of plain text, such as newspaper stories, generally yield about the same relative frequencies for letters. A sample of 1,000 letters long yielded in the information in the table. So this is our table. Frequency of letters in a 1,000 letter sample. Here, for the probability distribution, we use relative frequency, that is F over N. So we all know that this is a 1,000 letter sample. So for example, for letter A, the probability is equal to its F, 73 divided by 1,000, that gives us 0.073. For let us say B, we have there frequency of 9 divided by 1,000, it gives us 0.009. Okay. So the question is, if a letter is selected at random from a newspaper story, what is the probability that the letter will be a vowel? So, we have there the probability that the letter selected at random will be a vowel is equal to the probability of A plus the probability of E plus the probability of I plus the probability of O plus the probability of U. Okay, so for the probability of A, we have 0.073. For the probability of E, we have 0.130. Then for the probability of I, we have 0.074. Plus the probability of O, we have 0.074. And for the probability of U, we have 0.027. Okay, so for the probability that the letter will be a vowel, we have there 0.073 plus 0.130 plus 0.074 plus 0.074 plus 0.027 gives us 0.378. Okay, that is the probability that the letter selected at random from the newspaper story is a vowel. Next is for the mean and standard deviation of a discrete probability distribution. So the mean and standard deviation of a discrete probability distribution are found by using these formulas. We have for the mean, we have mu is equal to the summation of x times the probability of x. The mean is also known or called as expected values or mathematical expectation. Or it can also be called expected earnings. Okay? So for the standard deviation, it is sigma is equal to the square root of the summation of x minus mu squared times the probability of x, where x is the value of a random variable and the probability of x is the probability of that variable. The summation is taken for all the values of the random variable. Okay? So, again, for the expected value, that is the mean of a probability distribution that is often called expected value of the distribution. This terminology reflects the idea that the mean represents a central point or cluster point for the entire distribution. For our example problem, are we influenced to buy a product because we saw an ad on TV? So, National Infomercial Marketing Association determined the number of times buyers of a product watched a TV infomercial before purchasing the product. So, the results are as follows. We have there the number of times the buyer saw the infomercial and the percentage of buyers. Okay, so in this problem, it doesn't mean that the frequent the buyer saw the infomercial, the higher the percentage of their buying pattern. Okay? So for we need to compute for the mean and standard deviation of this distribution. Okay? So we have there our x will be the frequency that the buyer saw the infomercial. We have 1, 2, 3, 4, 5. And the probability of x is the percentage of buyers. That would be 0.27, 0.31, 0.18, 0.09, and 0.15. Let us get the x times the probability of x. We have there 0.27, 0.62, 0.54, 0.36, 0.75. Then, we have here, mu is equal to the summation of x times the probability of x. That is, it gives us 2.54. Okay? So, to optimize the number of times we show the infomercial, we need how many times? 3 times. Okay? So, let us compute for the standard deviation. Again, for our standard deviation, that is sigma is equal to the square root of the summation of x minus mu squared times the probability of x. So here, we get the x minus mu squared times the probability of x. So we compute for that. For this, we have 1 minus 2.54 squared times 0.27. 2 minus 2.54 squared times 0.31. Then 3 minus 2.54 squared times 0.18. 4 minus 2.54 squared times 0.09. Then 5 minus 2.54 squared times 0.15. Okay? So, we get the sum. We have there 1.86. 84. So this is not our standard deviation. This is our variance. Okay, for the standard deviation, we get the square root of this. Our sigma is equal to the square root of 1.8684 and sigma is equal to 1.366894 or 1.37. Okay? So that's it. Another example, at a carnival, you pay $2 to play a coin flipping game with 3 fair coins. On each coin, one side has the number 0 and the other side has the number 1. You flip the 3 coins at one time and you win $1 for every one that appears on top. Are your expected earnings equal to the cost to play? So for this one, we need to list down all possible outcomes for the coin. We have there 2 sides, 0 and 1, and we have 3 coins. Okay, so we have 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 1, 1, 1, 0, 1, 0, 1, 0, 1, 1. Okay, so these are our outcomes. We have 8. Then, so our concern is for every one that appears on top. So it can be there is no 0, there is no 1, there is 1, there is 2 ones, and there are 3 ones, or all of the coins has 1. So this will be our x. And what is the probability of this x? For 0, we have how many? We have only 1. So that is 1 over 8 or 0.125. So for 1, we have 1, 2, 3. That's 3 over 8. That is equal to 0.375. For 2, we have 1, 2, 3. That is 3 over 8. That is equal to 0.375. And for 3, we have 1 over 8. That is 0.125. Then let us compute for x times the probability of x. We have there 0, 0.375, 0.75, then 0.375. Okay? For the summation, we have there 150. So our expected earnings is only 150 while we are paying $2. Okay? Next is binomial probabilities. So when a problem is characterized by the feature that there are exactly 2 possible outcomes for each trial of interest, it is called binomial experiment or Bernoulli experiments. For the features of a binomial experiment, there are a fixed number of trials. We denote this by letter N. The N trials are independent and repeated under identical conditions. Each trial has only 2 outcomes, success, that is denoted by S, and failure, denoted by F. For each individual trial, the probability of success is the same. We denote the probability of success by P and that of failure, Q. Since the trial results in either success or failure is P plus Q is equal to 1 and Q is equal to 1 minus P. So the central problem of a binomial experiment is to find the probability of our success out of N trials. Okay? So we have there fixed number of trials, independent and repeated under identical conditions. Okay? Then, this is the general formula that we're going to use for binomial probability distribution. We have there P of R is equal to C and R. This is the coefficient of the binomial experiment. Then, times P, the probability of success raised to R, times Q, the probability of failure raised to N minus R. Okay? So, C and R is called the binomial coefficient. Okay? So, next, for our example problem, privacy is a concern for many users of the internet. One survey showed that 59% of the internet users are somewhat concerned about the confidentiality of their email. Based on this information, what is the probability that for a random sample of 10 internet users, 6 are concerned about the privacy of their email? Okay? So, what are the given values? We have there P of 59%. So that's 0.59. Then our Q is, if P is 0.59, our Q is what? We have 0.41. That's 1 minus P, 1 minus 0.59. That is 0.41. Our N is 10 and our R is, we have 6. So, for P of R is equal to 6, that is equal to, we have 10C6 times 0.59 raised to 6 times 0.41 raised to 10 minus 6, which is 4. So that is equal to, we have 10C6 times 0.59 raised to 6 times 0.41 raised to 4. We have there 0.25. Okay? Another example. A biologist is studying a new hybrid tomato. It is known that the seeds of this hybrid tomato have probability of 0.70 of germinating. The biologist plants 10 seeds. What is the probability that exactly 8 seeds will germinate, and what is the probability that at least 8 seeds will germinate? Okay, so for the given values, we have there P is 0.70. Our Q is equal to 0.30. Of course, that is from 1 minus P, 1 minus 0.70, that is equal to 0.30. For our N, we have there 10 and R is 8. Okay? For the first problem, what is the probability that R is exactly 8? We have there P of R is equal to 8 is equal to 10C8 times 0.70 raised to 8 times 0.3 raised to 10 minus 8, or that is equal to 2. So we have there 10C8 times 0.7 raised to 8 times 0.3 raised to 2. We have there 0.23. Okay? Then next, what is the probability that at least 8 seeds will germinate? So that would be P of R is greater than or equal to 8. That is equal to P of 8 plus P of 9 plus P of 10. So we already have our P of 8, that is 0.23. What about P of 9? That is 10C9 times 0.7 raised to 9 times 0.3 raised to 1. For 10, we have there 10C10 times 0.7 raised to 10 times 0.3 raised to 0. So we have here 0.23 plus, you have 10 shift combination 9 times 0.7 raised to 9 times 0.3 raised to 1. We have there 0.121 or 0.12 plus for 10, we have there we have 0.028. Okay? So we have 0.23 plus 0.121 plus 0.028. We have 0.379. 0.379. Okay. What about if there is a follow-up question? What if we want to know the probability of R is less than 8? Okay? So for R is less than 8, we have there probability of R is less than 8. That is equal to 1 minus the probability of R is greater than or equal to 8. And that is 1 minus 0.379. That is equal to 0.621. Okay? Another example. The probability that Kyla will score above a 90 on a mathematics test is 4 over 5. What is the probability that she will score above a 90 on exactly 3 of the 4 tests this quarter? Okay? So for this one, we have our P is 4 over 5. That is, 4 over 5 is 0.8. So if P is 0.8, what is our Q? Q is 0.2. Then our N is how many tests? We have 4. And our R is, we have exactly 3. That is, R is equal to 3. We have P of R is equal to 3 is equal to 4C3 times 0.8 raised to 3 times 0.2 raised to 1. So our answer is combination 3 times 0.8 raised to 3 times 0.2 raised to 1. We have there, okay, 0.4096. Okay? Okay, another example. Hospital records show that of patients suffering from a certain disease, 75% die of it. What is the probability that of 6 randomly selected patients, 4 will recover? Okay? So here, our concern is for the patients that will recover. So, this data, or this value, 75%, this will be, since it's about dying, that will be our Q. That is 0.75. Okay? So for our P, that is 1 minus Q, we have 0.25. Our N is 6. Our R is 4. So we have here P of R is equal to 4. That is equal to, we have 6C4 times 0.25 raised to 4 times 0.75 raised to 2. We have P of R is equal to 4. That is equal to, okay, so we have there 0.0329959, or we have there 0.03. Okay? Okay. Next. Another example. In the old days, there was a probability of 0.8 of success in any attempt to make a telephone call. So this often depended on the importance of the person making the call or the operator's curiosity. Calculate the probability of having 7 successes in 10 attempts. So we have there, P is 0.8, Q is 0.2. Okay? Our N is 10, our R is 7. So we have here, P of R is equal to 7 is equal to 10C7 times 0.8 raised to 7 times 0.2 raised to 3. So we have there, times 0.2 raised to, okay, so we have there 0.201. Okay? Okay, another example. A manufacturer of metal pistons finds that on the average, 12% of his pistons are rejected because they are either oversized or undersized. What is the probability that a batch of 10 pistons will contain A, no more than 2 rejects, B, at least 2 rejects? Okay? So for no more than 2 rejects, we have here, okay, what are the given values? We have P is equal to 0.12, Q is 0.88, since our concern is for the rejects. Okay? Then our N is how many? We have 10. Okay? So, for P of R is less than or equal to 2, we have there P of 0 plus P of 1 plus P of 2. Okay? So, we have here, what is our P of 0? We have 10C0 times 0.12 raised to 0 times 0.88 raised to 10 plus P of 1, that is 10C1 times 0.12 raised to 1 times 0.88 raised to 9. Plus, what about P of 2? We have there 10C2 times 0.12 raised to 2 times 0.88 raised to 8. Okay? So, we have there 0 times 0.12 raised to 0 times 0.88 raised to 10. We have 0.2785 for the P of 1. We have there okay, 0.3798 plus for 2 we have there okay. So we have 0.2785 plus 0.3798 plus 0.2330. We have there 0.8913. Okay? Then, for P of R is greater than or equal to 2, that will be 1 minus the probability of R is less than 2. That is equal to 1 minus P of 0 plus P of 1. So we have your 1 minus 0.2785 plus 0.3798. So we have here 0.3417. Okay? Okay, another example. After studying a couple's family history, a doctor determines that the probability that any child born to this couple having a gene for disease X is 1 out of 4. If the couple has 3 children, what is the probability that exactly 2 of the children have the gene for disease X? Okay? So we have here, our P is 1 over 4, that is 0.25. Our Q is 0.75. Okay? Our N is what? We have 3. And then our R is 2. Okay? So P of R is equal to 2 is equal to, we have 3C2 times 0.25 raised to 2 times 0.75 raised to 1. It gives us, we have 3. We have there 0.1463. Okay, so that's all.